Hi, my name is Kennedy Smith, and I'm doing my math project 2 on the distributive property of multiplication. So to start, let's start with the definition. The distributive property of multiplication states, when you multiply a number by the sum of two or more numbers, it's the same as multiplying the number by each of those numbers separately and then adding the products together, essentially distributing the multiplication within the parentheses. So to start, let's go over the formula for this property. So the formula for the distributive property is going to look like A times B plus C is equal to A times B plus A times C. So that is just going to be our baseline formula. So with that in mind, we're going to start off by showing an example. So our first example, we're going to show with numbers and then showing how we can illustrate it to maybe help understand a little bit better. So our first set of numbers, let's just do 3 times 2 plus 4. So in doing this, we are going to start with our first multiplication, which is going to be 3 times 2. So for 3 times 2, we're going to make 1, 2, 3 dots, and it's twice, so we're going to do that twice. So there we have our representation of the first thing, which is 3 times 2. For our second is going to be 3 times 4. So we already have our column of 3, which doesn't change, but we need to add 4 more. 2, 3, 4, and just go ahead and fill all of those in. So now that we have our second one, 3 times 4 illustrated, we can see that we have 3 times 2 plus 1, 2, 3, 4. So 4 plus 2 is 6. So we have a essential rectangle that's dimensions are 3 times 6. So by getting that, we can do 3 times 6 equals 18, which we all know is true. Or we can see it this way. We can go ahead and do the same thing, except we illustrate them separated. So we can have the 3 times 2 part just the same, and we can have the 3 times 4 part, except for they're separated, so we can see the difference of the two separate multiplications going on. So with that, we would just add them. So we have 2 by 3, which is 2 times 3, plus 3 by 4, which is 3 times 4. So 2 times 3 is 6, plus 3 times 4 is 12, which is equal to 18. Or we can do it this way. We can write out our formula again, and we can see it as 3 times 2 plus 3 times 4, 6 plus 12 equals 18. All three of these ways will lead you to the same answer, which is something that I like about math, but we can see clearly that we get the same thing, and we can just use what works best for each of our brains for solving those types of problems. Let's go ahead and do another one. So I'm going to erase this one. Okay. This one now, let's use numbers 4 times 2 plus 2. So as we can see, they're the same inside of the parentheses. So for illustrating that, we can do this 4 times 2, which is going to be our first one. So we do 1, 2, 3, 4 twice. And for our second 4 times 2, we can change our color and do 1, 2, 3, 4, 1, 2, 3, 4. So we see it the same. We can see our dimensions are 4 by 4. So we can see 4 times 4 equals 16. Or we can count all of our dots to get 16. There's many ways that you can look at it. but it will ultimately lead you to this. So that's just another example of just a simple regular distributive multiplication problem. Next, we can do it a little bit differently. So I'm going to erase this part. And for this, we're going to just show it a little bit differently. So we can also do A plus B in parentheses times C is equal to A times C plus B times C. So if we're adding numbers to this, we can go ahead and color code them by each variable. So for A, we're going to do 6. And for B, we're going to do 4. And for C, we're going to do 3. These colors are a little bit light, so that we will get 6 times 3, and we will also get 4 times 3. Color coding on this is a little bit hard, but you can see it. So we have illustrated this and color coded them. So A is the pink one, B is the purple one, and C is the yellowish one. So we can see that with these numbers. So we can see that it just becomes, this might be a quicker way, or it just becomes 2 multiplication problems that are smaller that you can just solve on your own. So with that, we would do 6 times 3 is equal to 18 plus 4 times 3, which is equal to 12, which will get us to our final answer of 30. And if we wanted to illustrate this, we could do 3, we could do times 6, just like our other examples. And then we can do 3 times 4. And this way, you can add them up, or you can see the 6 plus the 4 is equal to 10 times 3. And that's an easier way of getting our final answer of 30. So that is just a different way of looking at it. So for our next example, we're going to be looking at when we add another variable and don't only have just 3. So for this, the formula is going to look like A times B plus C plus D equals A times B plus A times C plus A times D. So if we're adding numbers to this, we can do 3 times 5 plus 2 plus 6 with A, let's do it down here, or let's do it over here. A equaling 3, B equaling 5, C equaling 2, and D equaling 6. So for that, we get 3 times 5 plus 3 times 2 plus 3 times 6. And within that, we can consolidate it and do 3 times 5 equaling 15, plus 3 times 2 equals 6, and 3 times 6 equaling 18. And with that, we get we can add 15 plus 6, which is 21, plus 18, and we can do it like this, or we get 9 and 3 to get our final answer of 39. However, smaller, we can do 3 times 5 plus 2 plus 6 equals, well, it's going to run into this. So that would be equal to 3 times 5 plus 2 is 7, so 7 plus 6. And 7 plus 6 is 13, so we can go 3 times 13, which is equal to 39. So either way, we get the same answer, and this is just with a little change with adding d as a variable. So another thing that we can do is use the distributive property to simplify some more difficult multiplication problems. So, for example, if we were going to multiply 21 times 50, you might not be able to do that off the top of your head, so we can simplify this into 20 plus 1 times 50. So A plus B times C. Then we do this, so we have 20 times 50, and then we do this, so 1 times 50. So we have that broken down, which leads us to a further breakdown. I wrote this wrong, 20 times 50. So a breakdown of 20 is going to be 10 times 2 times 50 plus 1 times 50, which is just 50. So we know that 10 times 2 and then times 50. So we're going to do that, which will lead us to 10 times 100 plus 50. And then that will lead us to our final answer of 1,000 plus 50, which equals 1,050. So if you were doing this without a calculator, or if you just wanted to have a little bit of a breakdown, this would be an easier way of doing that. We can also show another one. So for our second example, let's just go with 29 times 50. So we can break that down into 30 minus 1 times 50, which then leads us to 30 times 50 minus 1 times 50. So if we distribute these, it brings us to this. So we have 30 times 50 and then negative 1 times 50, which then leads us to 30 times 50 being 1,500 minus 50 from the negative to the negative multiplying the 50. So we just subtract 50 from that, which gets us to our final answer of 1,450. So that just shows how the distributive property can help break down more difficult problems and make them more manageable and easier to comprehend when you see each step. Next, we are going to talk about the FOIL method, and I quite enjoy the FOIL method. I think it is one of the things that stuck with me the most throughout school. I always think back to it. I think it's a really good thing to remember, and you never really forget it once you remember or once you're taught it. So FOIL, it's all uppercase. I like to write it like that. And it stands for first, outer, inner, and last. So that is the acronym. And FOIL is basically like doing the distributive property twice. So I'm going to color code my letters for FOIL. I don't like how these colors work. So purple will be F, green will be O, red will be I, and then we'll do yellow for L. Make it a little bit darker. Yellow for L. So that is going to be how you remember first, outer, inner, last FOIL. So like I said, it's doing the distributive property twice. So I'm going to go ahead and show you an example of that. So let's do 3 plus 2 times 6 plus 4. So we're going to just go ahead and do, let's start with our F, which was purple. So that's first, which is 3 times 6. So we're going to go down here and do 3 dots 6 times, or across by 6, my bad. So then now we have a 3 by 6 block. So that was our first. Outer is in green. So we have our outermost numbers, which is going to be 3 times 4. So we're going to do that right here. 3, 4. So we have that as our outer number. Next is inner, which was red. So that's our innermost numbers, which are going to be 2 times 6. And we're going to put that down here. So that's a 2 by 6 block. And then our last numbers are going to be 2 and 4. And they fit perfectly right under there. So now we can see that we have 3, 2, 6, and 4, which is what we can see with these numbers up here. But we can just visualize them down here. And so over here, I'm going to go ahead and write FOIL. And we can see that that brings us to 3 times 6 for the first, 3 times 4 for the outer, 2 times 6 for the inner, and 2 times 4 for the last. So that is the basics of the FOIL method. And I'm going to show you how you can do it again. So I'm just going to leave this here, and I'll just erase everything below the FOIL. Okay, so we're keeping the FOIL acronym just so that we can remember. And for our next example, let's just go ahead and do 4 plus 2 times 1 plus 5. So this is going to be our next example. So instead of visualizing it, let's go ahead and write it out like this. FOIL. So for these, for first, we're going to see 4 times 1. For outer, we see 4 and 5, so 4 times 5. Inner, we see 2 and 1, which is 2 times 1. And then last, we see 2 and 5, which is 2 times 5. So 4 times 1 is 4. 4 times 5 is 20. 2 times 1 is 2. And 2 times 5 is 10. So we could further consolidate that. 10 plus 2 is 12, 20 plus 4 is 24, and then we can add them up, equaling to 36. And we can see that we have 4 plus 2 plus 1 plus 5. So 4 plus 2 is 6, and 1 plus 5 is 6, which that is just 6 times 6 is 36, but you can also use the FOIL method to get to that same answer. So ultimately, this is the basics of the distributive property for multiplication. I think it's a really good way method to use. I think that I still use it now, and it can apply to many different areas in math in different skill levels. And so I hope that these examples helped everyone learn and that I explained clearly. And thank you for watching.